Hey, Prob and Stats, Mr. Monahan here. We are looking at review 2 for chapter 1. This is 20 questions long. You should have tried all these questions already and shown your work, so as you go through, you can look at what you did right and what you did wrong. Number 1, if you flip a coin 3 times, what is the sample space? This one wants us to create a tree diagram for this. So, when we're flipping a coin, when you do that, your options are heads or tails. We're going to do heads or tails 3 times in a row. So on the first coin flip, we get either heads or tails. We have to do this 3 times since we have 3 coin flips. Every time you flip, you still have the option of heads or tails. It doesn't matter if you got heads on the first one or tails on the first one. So each time I'm going to branch out a heads and a tails out of what I already have, and this is a tree diagram for 3 flips. This column would be flip number 1, this would be flip number 2, this would be flip number 3. All right, if we want to know the sample space, that's what the question asked us here. What we would do is we would start to list out following the branches. So this top branch here is a result of going heads, heads, and then heads. The next one would be heads, heads, and then tails, heads, tails, and then heads, heads, tails, and then tails. Now that's all the ways to get a head first. Now we're at tail first. So tail, heads, heads, tail, heads, tails, 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 heads, and tails, tails, tails. All right, normally we would use the curly brackets and list them. I'm just not out of space, so I'm not going to do that right now. So if they ask you what is the sample space, you're supposed to list them all out. Then the second question is how many total outcomes are there? If you count those up, we have 8. There's 8 different ways that can happen. That's number 1. Second one, how many different ways can 6 speakers be seated in a row on a platform? So 6 is our number this time. We're putting them in different orders, which means order matters. So since order matters, it's either going to be a permutation problem or a factorial. All 6 people, all 6 speakers are going to get a spot, which means that we are going to do 6 factorial. So that would be 6 with an exclamation point on this one. So that's 720 different ways that this can happen. So since everybody got a spot, all right, all 6 people, we use 6 factorial, okay, or it's like 6p6, picking all 6 people. Number 3, HS students all have a 6-digit student ID number. If the number cannot begin with 0, how many possible ID numbers are there? Digits may repeat themselves. How did I do that? So what that means is digits can happen again. Once they've been used once, we're allowed to use them again. The other rule we got to worry about, we can't have the first number be 0. We need 6 total digits in our ID number. So I'm going to make 6 blanks for this. Okay. What we're going to look at doing is figuring out how many digits are possible for each blank. The first blank that we have all the way to the left is representing our first digit. It can't begin with a 0, which means all the numbers 1 through 9 are possible, and so that's a total of 9. There's no rules about the 2nd through 6th digit, so all the digits 0 through 9 are possible for all of these. So digits can repeat, which means I don't need to knock it down by 1 each time. So the first one has 9 possibilities. The rest of them have 10 options. A student ID can repeat a bunch of numbers. So if you punch all that in, you get 900,000. That's how many student IDs are possible if you can't start a student ID with a 0. Number 4, how many 5-digit zip codes are possible? There's no rules about this. They didn't say anything about the first digit or the last digit or anything like that. Our zip code in Elk River is 55330, so obviously repeats are okay. So this one is 10 to the 5th power, essentially, is another way to write it. And what you end up with is 100,000 zip codes. Okay. If you typed it in with the comma or without it, you should have got it correct. I think both were possibilities. Okay. So let's move on to number 5. 5 people have to give a speech today in your English class. How many different orders can they speak in? So order matters. All 5 people are going to present. So if we're picking all 5 of the people, that means everybody has to speak. That's a factorial situation. All right, it's factorial since all 5 people will have to go eventually. We're just trying to figure out how many different orders could those 5 people speak in. So that's 120. Number 6, how many ways can a committee of 5 be selected from a staff of 20 people? So 20 people is going to be our N, 5 is going to be our R. Of the 20 people available, we need to pick, or choose, I should say, 5 of them. So since order doesn't matter for this problem, it doesn't matter because all we care about is that our group of 5 gets picked. We're not giving them specific jobs or anything that makes these different. So we're doing 20 choose 5, which is 15,504 different 5-person committees. That was number 6. So number 7, how many ways can you create a password that must begin with a digit? So this has to be a digit. Then it's followed by 2 letters. I'm just going to do it this way to save some time. 2 letters followed by 3 more digits. So I'm just going to go number, number, number. Okay? So this is another fundamental counting principle. We're just multiplying all the ways we can do something. This one does tell us we cannot repeat. This one says no letters or digits may be repeated. So for the first digit, we can do any of 10 options. Okay, there's 10 digits. For the first letter, we have any of 26 options. But then our second letter, we only have 25 possibilities. So we have to knock that down by 1. For the next digit, we have to use the number 9 because we've already used 1 digit. That was our first blank. And then the next one has to be 8. And then the next one has to be 7. So we have 10 times 26 times 25 times 9 times 8 times 7. So this would be representative of how many passwords are possible. If you punch that in, you get 3,276,000 passwords. So let's move on then to number 8. A 5-question multiple choice test has 3 possible answers, A, B, or C, for each question. So there's 5 questions total. There's 3 possible answers for each question. How many different ways can you randomly bubble in the 5 questions on the test? So we have 5 questions. Each one has 3 possibilities. A, B, or C. So a lot of people might do this as 5 times 3. This is actually 3 to the 5th power, or you could just do 3 times 3 times 3 times 3 times 5 times. All right, when you do that, you get 243 different answer keys. Okay? So with that one, probably not a good idea to guess. You have a 1 in 243 chance of getting 100%. Number 9, you are building a sundae. There are 5 flavors, 3 types of sauce, and 4 toppings to pick from. How many sundaes are possible if you want 2 flavors 1 sauce, and 2 toppings. So I'm just going to try to color code this for us. This is a compound combination. It doesn't matter what order you pick the 2 flavors. If you get vanilla and then chocolate, that's the same as chocolate then vanilla. So what we're going to do is just one thing at a time. We have 5 flavors that we want to choose 2 of. Okay, then we're done with flavors. Then we're on sauce. There's 3 sauces we want to choose 1 of. And then there's 4 toppings that we want to choose 2 of. So that's how this one would work. We have 5 choose 2 times 3 choose 1, and then times 4 choose 2. And you should get 180 different sundaes if you punch that in correctly. So with those ones, I would just take one category at a time. Start with flavors, then types of sauce, and then toppings, and multiply it all up. Number 10, you are building a sundae. There are 5 flavors, 3 types of sauce, and 4 toppings to pick from. What if we only want 1 of each? You could sure do it the same way we just did. So you could do 5 choose 1 times 3 choose 1 times 4 choose 1. That's completely fine. But if you're only picking 1 of each, this is really the same as 5 times 3 times 4 different sundaes. So really, that's another way to think about it. These 2 are equivalent. These equal each other. All right, they're the same thing. So we really don't have to pick which way is better. If you punch in 5 choose 1, you just get 5. 3 choose 1 is 3. 4 choose 1 is 4. But there's only 60 sundaes you can make when you only are picking 1 of each. 1 flavor, 1 sauce, 1 topping. Okay, we're halfway home. We're on the 11 now, and then there's 20 questions. So we've done exactly half. How many ways can a first, second, and third place winner be chosen from a group of 8 contestants? These are 3 different awards. So now order matters again. We are not picking everybody. We're just picking 3 people out of the 8 that we are concerned with here. So we have 8 people. We are going to use permutations because order matters. Order matters since first, second, and third place are all going to be different. So 8 picking 3 is 336. There's 336 ways that first, second, and third can be awarded. We didn't use C because first place is different than second place, which is different than third place. Number 12, create a grid that shows a sample space for the sum of 2 3-sided number cubes. Here's my grid. Each cube has 3 sides on it. If you get one like this on the test, make sure you look for, are we adding or are we multiplying? This time we're adding. So in this box, we have 1 plus 1. And you can see how I filled out the rest of it. Okay. So that's the grid that shows the sample space. Here's the sample space then. Every number between 2 and 6 is possible. We can't get a 1, we can't get a 7. Which sum shows up the most? Well, that would be 4. There are 3 different ways to get a 4. Number 13. There are 35 students in class. That's an important number. 22 said they love math. I'm going to make a math circle. 8 said they love English, but not math. So here's English. 3 said they love both equally. So I'm going to take the both number and put it right into the overlap. That's how many love both. 8 people said they love English, but not math. So that's another way of saying only English. So 8 people love English that don't love math. So that's different than the 3 people that are in the overlap. 22 total people said they love math, but we already have 3 that we already have in the math circle, so we need 19 more. Remember, if it doesn't say only, these 2 numbers have to equal 22. So we can't put 22 in there right away. All right. Okay, so then we have 22 plus 8 is 30. So there's 5 people that don't like math and they don't like English. They don't like either one. All right, so that's our first answer. How many don't love either one? That would be 5. How many students love only math? Those are the people that are in the math circle but not the overlap. That would be 19. How many love English? Is 3 plus 8, which is 11 total. Number 14, you have to make a 4-letter password. 4 blanks. How many passwords are possible? Letters may be used more than once. We can repeat. So we have 4 letters in a row. There are 26 possible letters to choose from in the alphabet. We can repeat, so A would be an acceptable password in this scenario. So right now we have 456,976 passwords. If you can repeat the letters, and it's a 4-letter password. Number 15. How many different words can be created out of using all the letters in the word probs? Okay, all those letters are different, and there's 5 letters there. So we're using all 5 of the letters in probs, which is 5 factorial, which we've had before, is 120. Number 16, Pompeii offers 8 different toppings for pizza. You only have enough money to buy a pizza with at most 3 toppings. How many different pizzas could you order? At most 3. We have to think about what that means. So that means we could get a 0-topping pizza, or a 1-topping pizza, or a 2-topping pizza, or a 3-topping pizza. That's at most 3. So let's figure out how this works. So or means add. So we're going to be adding up some possibilities here. Out of the 8 toppings, we could choose 0 of them. We could choose 1 of them. We could choose 2 of them. Or we could choose 3 of them. Those are our only options right here. We're going to figure out what all these are, and then we're going to add up our answers. So when it says at most 3 toppings, what that means is we have to think about how many ways to get 3 and all the ways to get less than 3. So 8 choose 0, that's just 1. There's only one way to choose 0 toppings. There's 8 ways to choose 1 topping. There are 28 ways to choose 2 toppings when order doesn't matter. And there are 56 ways to choose 3 toppings. If you total all of those up, we have 93 different pizzas that we can order if we want at most 3 toppings. Number 17, a varsity basketball team must have 3 juniors and 2 seniors as starters. If the team has 5 seniors and 8 juniors on the roster, how many ways can he select his starters? And means multiply. So I want 3 juniors and I want 2 seniors. So there are 8 juniors available that I'm going to choose 3 of, and there are 5 seniors that I'm going to choose 2 of. So we have 8 choose 3, which we just said before was 56. Okay. If you do 5 choose 2 in your calculator, you end up getting 10. 56 times 10 is 560 different ways that we can pick the starters. So there was 5 seniors to pick from, we chose 2. There was 8 juniors to pick from, and we chose 3. Number 18, there are 5 spots left on the softball team. There's a tryout where 10 juniors and 5 seniors show up. The coach must pick at least 3 juniors. Okay, how many ways can the coach pick his team? So, at least 3. That means 3 juniors or 4 juniors or 5 juniors. This one gets a little bit complicated, okay? Because we're taking a total of 5 people as we look at this. So this is really, I should update this a little bit. We have 3 juniors and 2 seniors. That's one possibility. Okay, right here, that's one possibility. Or 4 juniors and 1 senior. That's another possibility. Or 5 juniors, but that would be 0 seniors. Okay. All right, so let's look at these. And means multiply. So if we have 3 juniors, that would be, there's 10 juniors to choose from, and we're choosing 3 times, and means multiply, of the 5 seniors, we're going to choose 2, plus the 4 juniors part, which is, we still have 10 juniors to choose from, we're choosing 4, and of the 5 seniors, we're choosing 1 senior. Or of the 10 juniors, we pick all 5 to be juniors. So that would be 0 seniors. You can do times 5 choose 0, but that's just going to turn out to be 1. Okay, 0 seniors. Okay, and this would be and 0 seniors. Okay. All right, so we have a lot of punching in to do here. So let's just get some of these going. Why don't you pause the video, and I'll actually punch it in too, and then you can see what if you get the same thing as me. Perfecto. Go ahead and check out your calculator work there. 2,502 would be the amount of ways that we can get this done. Okay, 2 left, number 19. How many 5-card hands can have exactly 3 queens? Okay, this is a little tougher than maybe the notes had done, but let's talk about this. So we want 3 queens, and so we have some multiplying, 2 non-queens. Okay? Order doesn't matter for these card problems. So there's only 4 different queens in the deck. We want to choose 3 of them. So if you think about the other 2, we want to choose 2 other cards. So when we do that, we want to look at how many cards in the deck are not queens. So to figure that out, you think about there's 4 queens and there's 52 cards in the deck. You end up with 48 cards that are not queens. So we're doing 4 choose 3 and 48 choose 2, so we're multiplying those 2 things together. 4 choose 3 will be 4, so 4 times 48 choose 2 is 4,512 different ways to get exactly 3 queens. Okay, last one. A family has 2 children. How many different ways can the family be made up as far as boy or girl? All right, so you can do this with a tree diagram since they want the sample space. We could do this just with some simple math, but they want us to make sure everything's listed out. So we could have a boy or girl for the first child. We could have a boy or girl for the second child. There's only 4 different ways this can happen. So the first answer would be 4 ways. The sample space is right here then. We could have a boy and then a boy. We could have a boy and then a girl. We could have a girl and then a boy. Or we could have a girl and then a girl. So what I would do is do this quiz again. I would put the answers to the side and try them all again. Now you have a really good answer key for everything that we need to do. Thanks for watching. Keep studying so you're ready for the test.